Hey guys, and welcome to 2.6. In this lesson, we're going to talk about the combination of functions and composite functions. A lot of the conversation around this lesson is, what is your domain? And there are a couple things you need to watch out for when it comes to finding your domain. And that is, do I have a denominator, because I can't divide by 0? Do I have a square root, or an even root, rather, because I can't take square root of a negative number, or an even root of a negative number. If none of those things are in my problem, then my domain is all real numbers, which is what it wants to be. So for like number 1, it's just a basic polynomial. There is no roots, there is no fractions, so my domain is going to be all real numbers. And I write that in interval notation, negative infinity to positive infinity. Number 2 is a little more complicated because I have a fraction. You can't divide by 0, so we're going to find out what makes the whole thing 0. So I'm going to set the whole thing, I'm going to factor x squared plus x minus 110 equals 0. I'm going to factor that. That's going to be x 10 times 11. All right, 11 is bigger, so I guess it's down in the middle. So it's going to be plus 11 minus 10. You're going to set each one of those equal to 0, and when you do, you're going to find that x is equal to, let me just show you. I got x plus 11 equals 0, so that's going to be x equals negative 11. X minus 10 equals 0, so that's going to be x equals positive 10. And so those are where your holes in your domain are going to be. And so you write your domain from least to greatest, and that's going to be negative infinity to your lowest number, which is going to be negative 11. You hop over, you get negative 11 to 10, and then you hop over, you do 10 to infinity. So you have two holes, and here's where they are. And you have the union in each of these. Okay? Number 3 is a little more complicated. Number 3 is a little more complicated because of how that fraction is set up. You have a fraction within a fraction. Okay, so you have to look at two scenarios. The first one you want to look at is you want to set the entire bottom equal to 0. So it's going to be 20 over x minus 5 minus 2 equals 0. The second one is you want to take the second fraction, the 20 over x minus 5, and you want to set the x minus 5 equal to 0. All right, and then you want to solve each of these for x. So I'm going to see 20 over x minus 5 equals 2. I'm going to multiply both sides by x minus 5, so it's going to be 20 equals 2 times x minus 5. Now, I could distribute the 2 and then work to get x by itself, but I know that 2 goes into 20, so I'm going to go ahead and divide, and it's going to be 10 equals x minus 5. And I'll add 5 to both sides, so that's going to be x equals 15. And then here it just simply says x equals 5. So just like number 2, I have two holes in my graph at 5 and 15, and I'm going to write my inequality very similarly. So this is going to be negative infinity to 5, 5 to 15, and 15 to infinity. And that's how you do it. That's your domain. So again, on these first few problems, all you're doing is trying to figure out what makes my denominator 0, or what is going to break my domain. And then whatever it is, you write your domain with those breaks in it. All right, so number 4, I said at the beginning of this that the only thing that's going to cause a domain issue is a fraction, because you can't divide by 0, and then a even root. This is the square root of number 4. All right, it can be 0. I can take the square root of 0. I can't take the square root of negative 1. So it can be 0 or anything above 0. So I'm going to take whatever's inside. Just like in a fraction, I take the entire denominator, set it equal to 0. I'm going to take the entire inside of this thing and say x plus 3 is greater than or equal to 0, because it can be 0 or it can be greater than 0. It can't be less than. All right, so I'm going to solve this. So it's going to be x is greater than or equal to negative 3, and that's your domain. So I just need to write that. That's going to be negative 3, comma, infinity, because of that equal to is going to be a bracket and then positive infinity. If you need to draw the graph first, that's fine. If that is how you go, if that's how you understand interval notation, is to draw the graph first from the inequality and then do the interval, that's fine. On number 5, I have two roots, so I have two things to solve for. And so you have x minus 9 is greater than or equal to 0. X plus 3 is greater than or equal to 0. Okay, well, this is going to be x is greater than or equal to 9. X is greater than or equal to negative 3. Now, I understand if you need to draw the graph on this one, because you got two things going on, you need to know which one you're going to pick. You want the one that's most restrictive. All right, so for instance, negative 3 is less than 9. So if I picked, let's say 0, 0 works for half the problem. It doesn't work for the other half of the problem. Like, I cannot plug in 0 to this thing and get an answer, because it spits out a negative 9, and that breaks the entire thing. So I need the one that's most restrictive. I don't want this one. I want this one, because that's the one that's most restrictive. There you go, most restrictive. Number 6. So this one you have to factor by grouping, which you should be familiar with. All right, this is simply going to be, let's see, I'm going to pull out an x squared. This is going to be x minus 1. I'm going to pull out negative 4. It's going to be x minus 1. All right, so it's going to be x minus 1 times x squared minus 4. All right, x minus 1 is good. X squared minus 4 is the difference of two squares, so I have to keep factoring until I'm done. So it's going to be x minus 1, x plus 2, x minus 2. All right, so x equals positive 1 and plus or minus 2. It's going to give you positive 2 and negative 2. So again, you have to write your domain from negative infinity to positive infinity and include all of these breaks. So you have a hole at negative 2, a hole at 1, a hole at 2, and that's how that's written. Okay, so on number 7, I'm going to take my two functions, f of x and g of x, add them together, subtract them, multiply them together, and divide them. And each time I'm going to find the domain of each one. So it's actually pretty simple. It's not as bad as you think it is. So for the first one, this is going to be f plus g. So I'm going to take this is going to be square root of x plus x minus 12. Okay, well, the only thing that's going to break my domain is the root, and that's simply going to be x is greater than or equal to 0. That's what I would set up and solve because that's what's underneath the radical. All right, but there is nothing to solve. It's just greater than or equal to 0. So my domain here is going to be x is greater than. You could write the. It really depends on what Pearson wants, but you could write the inequality. If you wanted to write the interval, it would be 0 included, and then go into infinity. That's what it looked like. Okay, so you have f minus g. So that's going to be the square root of x minus. So minus parentheses x minus 12. You're going to distribute that parentheses. And so it's going to be square root of x minus x plus 12. Okay, so this is the same as the first one. The x and the 12 are not going to do anything to my domain. This is still the square root. So my domain here is going to be the same as it was before. When I do the multiplication, all right, let's see, I got square root of x times x minus 12. Now, whether I distribute that or not, once again, the square root of x is the thing that breaks my domain. And so my domain hasn't changed yet. Let's see if it changes when I divide. So I have f over g. Okay, so that's going to be the square root of x on top, x minus 12 on the bottom. Well, because my numerator is the square root of x, I know that domain. All right, so let's talk about this. So I'm going to have a domain issue on top of it can't be less than 0. All right, and then on the bottom, it can't be positive 12. So if I say x minus 12 equals 0, you get x equals 12. So that's going to break my graph here. So my domain on the bottom is going to be negative infinity to 12, union 12 to infinity. Your domain for this entire thing is a combination. All right, where do they overlap? Okay, so the bottom goes all the way to negative infinity, but the top won't allow that. So you're going to cut it off where the top ends. All right, so your overall domain for this one is going to be 0 to 12, because you still have that hole at 12, and then 12 to infinity. So it's still 0 to infinity, but now you have a hole at 12. All right, so that's number 7. All right, number 8. This is a combination of functions, or rather a composite function, and you see f of g of x like this. Sometimes you can think of it as fog or goth or anything like that, but it's not an actual. It's not O. It's a symbol. All right, and I personally don't like the way they write this. And so if you look up here at the top, f of g of x is actually written this way, or it can be written that way, and g of f of x can be written this way. And I think it's more appropriate to write it these ways because it tells you exactly what you're doing. You're taking one function and putting it in the other, and it tells you, am I putting g into f or f into g or whatever it happens to be. And so that's how I want to approach this. Okay, so f of g of x, that's what the solution is going to be. So all in all, I'm going to take f of g of x, and then I'm going to plug 2 into it. And then I'm going to find g of f of x, and then I'm going to plug 2 into that. So I got 4 things I need to solve for. So f of g of x is, I'm going to take g of x and plug it in. So that's going to be x squared minus 5, all squared. Okay, well, if I plug in 2 to that, which is all I'm doing, then this is going to be 2 squared minus 5, all squared. Well, 2 squared is 4. 4 minus 5 is negative 1. And negative 1 all squared is positive 1. So there's your answer there. Okay, and then on the next part, I'm going to take g and plug it into f. Okay, so that's going to take x squared, square it, minus 5. So that's going to be the x to the 4th minus 5. X to the 4th minus 5. All right, and then you have g of f of 2. And that's going to be 2 to the 4th minus 5. That's 16 minus 5, which is 11. All right, and that's how it's done. Number 9, we're going to try to find f of g of x. And so I'm going to take g and plug it into f. Okay, and then ultimately we're going to find the domain of this thing. So f of g of x we're going to take 8 over x and plug it into the f function everywhere there's an x. Okay, so now we have fractions inside of fractions. Okay, well, I need a common denominator on the bottom, so I'm going to leave 8 over x alone for a second, and when I get the common denominator, it's going to be x, and so this is going to be x over x, or rather 8 plus x over x. Now, this is 8 over x divided by this fraction, and when you divide fractions, you multiply by the reciprocal, so I'm going to change this to multiplication and flip that fraction, so that's going to be x over 8 plus x. And now you can see that my x's are going to fall out, and my answer is going to be 8 over 8 plus x. So that is the result of plugging g into f, but let's think about the domain for a second. All right, when I look at, nothing really matters until I start to plug in. And so when I plug in and I get 8 over x plus 1, you set both of those equal to 0 and solve. Well, obviously, on top, like x is just 0. So I know that that's not going to be x equals 0 there. And then 8 over x plus 1 equals 0. That's going to be 8 over x equals negative 1. So 8 equals negative x. And then x equals negative 8. Okay, so I have a hole at 0 and negative 8. At 0 and negative 8. Okay, so here I got negative infinity to negative 8. Union negative 8 to 0, 0 to infinity. Okay, and that's how you do it. So you plug in g to f and then look at it. You don't simplify anything. You just look at it and see, okay, do I have fractions? Do I have roots? And then whether it's in the numerator or the denominator, doesn't matter. Any fraction, any root is going to present a problem for your domain, and you have to go find it. On number 10, we're going to find f of g of x here as well. So same concept. So f of g of x. And so I'm going to take g. So it's going to be 7 minus x squared plus 5. Well, when I simplify this, that square is going to take care of the square root. And so that's going to be 7 minus x plus 5. And so that's going to be negative x plus 12 for my answer. You could also write that 12 minus x if you were so inclined. Okay, now I need to find the domain. Remember, I plugged it in. I plugged g into f, and then I look at it. What's going to break it? Like before I do anything, what's going to break it? Well, that root still presents a problem. So let's take a look at that. That's going to be 7 minus x greater than or equal to 0. It's going to be negative x is greater than or equal to negative 7. X is less than or equal to positive 7. Okay, so it's less than because when you multiply and divide by negative, you change the inequality. So my domain here is simply going to be x is less than or equal to 7, and so it's going to be negative infinity to 7, bracket on 7, parentheses on infinity, or negative infinity. Okay. All right. So number 11 is this idea of a decomposing functions, where it says h of x is the combination of f of g of x, which is kind of what we've just been doing. We take g, plug it into f, but h says that's already been done, and I want to know what the two functions were. Now, because you're decomposing, this has multiple answers to it, because people have different interpretations. But here's the easiest way to do it. First of all, f of x, g of x. You have an outside function and an inside function. F, in this case, is my outside function. G of x is my inside function. Okay, so what is the thing, what is the function that got plugged into? So if you look at the big picture, I have a ninth root of something. Well, if I let that be the ninth root of x, that could be what I plugged into. And if that's what I plugged into, then what I plugged into it was 4x minus 5. And so if you see real clearly, if I were to put this back together, I would take g of x, 4x minus 5, plug it into f of x, the ninth root of x. And that would become what is now h of x, the ninth root of 4x minus 5. And so you can have different interpretations of this, but ultimately that's how it's done, is you just simply look at it. All right, what is a possible outside function? What is a possible inside function? All right, and then 12, you can't get easier than this. All right, they have two graphs, one for f, one for g. All right, and it says f of g of negative 3. So what it's asking you to do is you want to look at when is x negative 3. Okay, and then when x is negative 3, what is g doing? Well, g is 1. So this is another way of saying, all right, once you find that, then you can rewrite this and say f of negative 1. Because you know it, when you plug in negative 3 to g, you get negative 1. Okay, so let me say that again. So when x is negative 3, g is negative, oops, this should be positive 1. When g is negative 3, the function g is at positive 1. All right, so now I want to know what f of 1 is. Okay, and so when x is 1, f is 3. And so that's how you do that. Not too big of a deal. Okay? All right, guys, that's 2.6. I hope you got something out of it. If you have any questions, please reach out. If you need help using your calculator, you can reach out for that too. And I will see you in the next video.